Hello and welcome. My name is Aldo Bottelli and I'm Director of Engineering at True Circuits. Today I'm going to present to you our latest implementation of a high-performance DDR PHY. First, a little bit about the company. True Circuits is a leading provider of high-performance and general-purpose IP, namely phase lock loops and delay lock loops. More recently, we have introduced to our portfolio high-performance DDR PHYs, and they support all recent DDR and LPDDR protocols. The company was founded in '98 and is headquartered in Los Altos, California. We have an experienced analog mixed-signal team of engineers that implement the IP, and our IP implementation is characterized by a high use of automation that goes from the design phase, for example, during circuit characterization, all the way to layout implementation, for example, during porting to new technologies, all the way to usage of high level of automation for parametric testing that we use during the testing of the silicon implementation of our IP in MPW test chips. The timing IP of True Circuits is characterized by being easy to use and programmable, and is available in a vast set of processes and technology variants. Over the years, True Circuits has partnered with foundries, many foundries, including TSMC, Global Foundries, and UMC. And our global customer set include majors, IDMs, OEMs, and design services firms. Like I said, I'm going to introduce to you our high-performance DDR PHY, and our implementation stands out for these characteristics. Is a high-performance implementation that achieves the highest data rates available in the latest DDR and LPDDR protocols. And it stands out for its simplicity during integration. For integration, it's very easy to reach timing closure, and is also characterized by a high level of automation. It enables the user to lower system cost for DDR system implementation, and also it allows a simple bring up phase of the DDR system. So I highlighted the important points that characterize the PHY implementations, and I'm going to go through each one of the points to highlight some details. It's high performance, and in fact our latest implementation achieves 6400 megabit per second in LPDDR5 protocol. The architecture is based on our silicon-proven implementation of DDR4 at 3200 megabit per second that we realized in 28 nanometer HPC plus technology. And the high performance is reached basically through the heavily use of training, which is totally automated because these PHY components includes a lightweight special purpose processor that implements the training and requires no intervention from the user. In particular, the training that are implemented go from write leveling, data I training, read and write data I training, and some of them also run continuously in the background during mission mode, and in particular read gate training and read data I training. The system also allows to implement a low latency PHY. In particular, no transaction delay is required when addressing different ranks, and latency is programmable, so it can be optimized for every customer floor plan requirement. One of the major points is that it's simple to integrate, and then the PHY comes with a soft PHY component, and the hard macro is actually delivered to a customer with no assembly required. It's composed by a CA and data slice plus a clock generation hard macro, but also includes a hardened balanced clock tree that allows the timing synchronization of all the CA and data components. The soft to hard interface is actually included in PHY, so it's part of the PHY, and the is not exposed to the memory controller, so this simplifies integration. And easy timing closure is achieved through the usage of source synchronous clocking. The PHY is DFI 5.1 compliant. It supports DFI ratio of 1, 2, and 4, and it includes industry standard DFT features, and for the hard macros, it includes a loopback-based BIST that allows for full test of the data path, including write and read data paths. The PHY includes a PLL, so the providing a low-quality reference clock is sufficient, and the PLL basically generates is used for clock generation for all the CA and data components, but also for the clocks that go to the soft components, including the memory controller. The PHY includes on-chip voltage regulators for noise-sensitive circuits, and the I/O include multiple I/O drive strengths and termination settings. Another important point is to highlight how easy it is to reach timing closure with our PHY. The PHY is delivered with a soft macro component that communicates with a memory controller through the DFI interface. In particular, the DFI interface is a synchronous interface, so it requires no particular challenge in closing timing. And then it's delivered as a single unit hard macro that is tailored to the customer floor plan, that includes data slices and CA slices. Also includes a balanced clock tree that allows for timing synchronization of the data and CA slices. Yeah. And like I said, the interface between the soft and hard macros is implemented making use of source synchronous interfaces, where the only requirements is to route data and clocks in a way that the delay matches within plus or minus half a divided clock cycle. So the clock cycle is divided by the DFI ratio for the soft and components, so normally that requires no particular challenge in passing timing. The PHY also is characterized by heavily use of automatic training. The training is managed by a lightweight special purpose processor that allows basically to run the training with no user intervention. Training include, they are provided by True Circuits. The firmware for training is provided by True Circuits, and it includes write leveling, read gate training, and per pin read data I training, including the 5 VRF optimization, per pin write data I training, including the DRAM VRF optimization. Some of them can run continuously, and the special purpose processor can also be used for periodic training when that's necessary. The PHY allows the user to implement a low-cost system, and in particular automatic training compensates for static skews in the system, so that allows the user to lower the cost of package and board implementation. Also, it offers extensive visibility in the PHY and DRAM timing state, and it offers a lot of features for debug capability in the lab and in the field. These features also simplify bring up of a DDR system, and in fact the visibility of the timing parameters help with that. The PHY also offer information gathering for jitter, for example, of any other timing issue that might present itself. It also offers ability to override system timing parameters. We can train using software only, and we can bypass the PLL if that's necessary. Silicon validation is another very important phase of DDR system development. We have developed a highly automated test and characterization environment that we use in our test chip implementations to validate system timing compliance, but also to characterize the robustness of training across system temperature and voltage variations. And this environment is available to customers if they request it. This is a picture of our silicon test boards. You can see on the left the daughter cards that drive the test boards. They include sockets with our test chip implementation. In summary, I presented a high-performance DDR PHY that allows a complete and scalable, the implementation of a complete and scalable high-performance DDR system. Fully automatic training is managed by an included lightweight special purpose processor. Some of the training is continuously running during mission mode reads. It's delivered as a single unit and is implemented tailored to the customer full plan implementation, including I/O placement. Easy timing closure is simple because of the usage of source synchronous clocking. It includes DFT features, including loopback based BIST for the analog macros, includes a PLL for clock generation. It allows to lower package and board costs, and it offers features to bring up a system and find issues quickly. The DDR PHY IP is available for all the different technologies supported by True Circuits. In particular, is readily available in TSMC 40 nanometer, TSMC 28 and 22 nanometer, and the more recent 16, 12, and TSMC 7 and 6 nanometer implementations. It supports protocols going from DDR3 and LPDDR3, DDR4, LPDDR4, all the way to LPDDR5, and future versions will also support DDR5. It's delivered to the customer floor plan as a hard macro with some additional soft logic, and it includes protocol-specific DDR IOs. Licensing is available for single and multi-use that include no royalties. Often comes with an option to license a third-party memory controller, and it can be associated to licensing other TCI timing IP. Thank you for your attention.